here's our video for like understanding what a free body diagram is and how to make them yourself. So this paper here, this first part has our 5 forces that'll be common and when they actually kind of apply. So just remember, your gravitational force is always drawn straight down. That one's going to be in every single one of these pictures. Tension forces are caused when something in the environment is like a string, and it's always going to be a pull. Applied forces can literally go any direction, so you have to use context clues to figure them out. Normal forces will always be a push out of a surface of some kind, and then friction forces will be generated when something is trying to slide along a surface. So I'm going to give you 2 example free body diagrams, and then I'm going to have you try the back side of this, where there's a total of 6. So let's start with our first example. So a child pulls a sled across a driveway at a constant speed. For these things, you could try to draw these out really nicely, and if you like art, that's great, good on you. I'm going to draw them as stick figures, so I apologize already for my art quality. But if you're really art challenged, you could literally just draw a rectangle and name it sled, and that'll do the trick. But let's draw our scenario. So we have a child, they are pulling a sled across a driveway. Now this is going to be a rope here, a string. Let's put a hand there because it looks a little bit weird if I don't. And then I'm going to draw a toboggan because those are a little bit more interesting to look at, I guess, as far as the way they look in a side profile. All right, so starting things off here with our little picture here. If we want to scroll on the list, we can do that. So first one on the list is a normal force. The sled is in contact with the surface; it's touching the ground. So that means the ground is going to be pushing on the sled, and it's going to be pushing upwards. So that gives us an Fm going up. All right. Friction force is caused when an object is sliding or trying to slide along a surface. This is sliding along the driveway, and if you recall, friction force is always push against motion. So if the kid's pulling the sled this direction, that means our friction force has to be going that direction. So let's draw that in. So we have our friction force. Applied force is caused when objects are pushed or pulled by a person, machine, or an animal. Now, I could see an argument for saying there is an applied force in this scenario, but I would argue that this kid isn't actually touching the sled. Something else is touching the sled. So I think the most correct answer does not include an applied force in this scenario. But what it does include is a tension force. What is touching the sled, what is actually pulling it forward, is this rope here. So we would have a tension force acting this way. And then finally, gravitational force, we always have that is always downwards. So this little drawing here is what a free body diagram, that's all it is. It's just a little picture that documents which direction forces are acting on an object. So we are actually done with this picture. Let's go on to our second example, and we'll see how that kind of plays out. So in our second example, we have 2 children. They're pulling opposite directions on a toy. So we're going to put that toy on a little play table thing, because it looks better to me. And we'll get really fancy with a little 3D picture. All right, so here's our toy. Okay, we have one kid standing on this side, pulling on that bear in one direction. And we have one child standing on the other side, pulling this way. So let's go through our forces. So the normal force, this bear is in contact with the surface. That's right there. So there will be an upward force of Fn. Okay. It doesn't say about sliding, and we don't know which way the bear will be moving, so we're going to leave friction force out of this, but if one kid did begin to win this, and it began to slide, we see a friction force going either left or right, depending on which kid was winning. The applied forces are caused by a person, animal, or machine pushing or pulling on our object, and indeed we have two. We have an applied force pulling this way from this kid, and we have an applied force pulling the opposite way from the other student, or the other child. So I'm going to label them FA1 and FA2 just because it's good form to have different names for each force. We have no strings in this, but we do have FG. That is always going to be acting. That'll be going downwards. So the other 6 questions, or 6 or 7 questions, I'd like you to try to tackle those ones. And when you have them done, just take a picture of your paper and send it to me over email or Google Docs or anything, any form you want. I'll make sure I put that into the gradebook. I do want to say one thing though, that the 2 examples we did see, they have 4 forces on them. That is not always the case. You can have as little as 1 force or 5 or 6 if you really want to get ambitious with a scenario. But I'm hoping that makes sense, and if you have any questions, feel free to email me or pop in for office hours. So until next time, I'll talk to you later.